In this problem, you are given a grid, and that grid cells represent either a piece of land or water. So inside the grid, 1 will denote land and 0 will denote water. So this is a binary grid, and outside the grid everything is water. And there is just one piece of land, and it's clearly mentioned in this question that you are given just one piece of land, so there will not be multiple pieces. So here what we have to do, we have to find the perimeter of this island. So in perimeter we will calculate this, the region highlighted in yellow, that is the outer regions. So this is 1 unit, all the cells are of 1 unit. So this is 1, this is 1, this is 1, 1, 1. So you have to outline this land and then count how many edges you find. So in this case it will be 16. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We started from here. So how we will calculate it? So here it's a simple problem, but I will try to give multiple solutions so that you get good understanding of how to solve it. If you want to solve it using DFS, then also you can use that depth first search, and it will be a recursive solution. But in this problem we don't require DFS, and we can do it with just one pass of this grid iteratively only. So let's look at both the solutions. I hope you will gain some understanding of how to write recursive code as well as iterative code. So first we will look at the simpler or more easier approach, which will be iterative approach. So here what we will do, we will start from this row. We will scan this row wise. So first row, then second row, and in each row we will scan all the cells. So if this is M cross N grid, we will look at all the M cross N, Mn cells. And what we will do, we come here, we look its neighbors. So there are 4 neighbors. These 4 neighbors are allowed, not diagonal, only 4 neighbors. So we will initialize a parameter. Initially perimeter is 0. Then we look at each of the cells. We come here, we see how many neighbors it has. It's a water, so we don't even consider. We come here, it's a land, so we know that we have to find its perimeter. So we will never come back at this cell. So that's why better look at all of its 4 sides, which of the sides have water. So in the top we have water, left we have water, right we have water, but bottom we have land. So 3 sides are surrounded by water. So this will be 3. These edges 1, 2, 3. So for I equal to 0 to row minus 1. So this is row, or you can say M, or rather R, and j equal to 0 to column minus 1. And if grid ij is 0, then we don't need to see. If it's water, then we are not bothered. Only when we find a land, we look at its sides, then continue. Don't process it. Else what we will do, you can do multiple things. You will first add a bound check that I is greater than 0, then see whether I minus 1 exactly left cell is water or not. If it's water, add 1 to perimeter. Look at its right. If it's 1, add 1 to water, add 1 to perimeter. Similarly, look at all the 4 neighbors. So accordingly, if left is water, perimeter plus plus. Similarly, if right is water, then again plus plus. Top is water, again plus plus. Bottom is water, again plus plus. So here we added 3. Let's run through it. Perimeter was 0. So what we did, we added 3 when we encountered this land. Then we come here, water, nothing to do. Then we come to next row. I becomes 1. So we come here, we see which sides are water. Left is water, top is water, bottom is water. 3 sides, so add 3. Then we come here, all 4 sides are land, so nothing to add. Here 3 sides are water, so again add 3. Then water, water, land. Again look at its sides, 2 sides are water. Then water, water, nothing to do. Then here 3 sides are water. Here 2 sides are water. And then we reach here, and that's the end of this loop. Let's add it 3, 3, 3, 3, 12, then 14, 16. So it's 16, which is correct. We can do it recursively also if you like. So let's see the recursive solution. We will follow the Dfs approach. So we know that we have just one piece of land. So we will start a Dfs and it will visit all the nodes. And in Dfs we need to keep track of visited nodes. So initially these are 0 or 1 values. So whenever we visit a land, we mark it as 2. That will denote visited. So we look at this row, we start row wise, and whichever is the first cell where there is a 1 or a land, we start Dfs from there. So we start Dfs from this is 0th row and 1 column. So start Dfs from here and also pass one global value, sum, or you can call it parameter. So what we will do, we will first mark it visited. So grid, let's call it I, let's call it J in general. So mark it visited. Then what we will do, we will look at its neighbors. So we look at its 4 neighbors, 3 of them are water, only 1 is land. So we add sum 3 times. Obviously we will write more code here. I am just for simplicity adding this 3. So here we added 3, marked it as visited, and look at its neighbors, whichever is land. If there is no land which is unvisited, then we are done, we return. So this is now marked 2 since visited. Then we look at its left, right, top, bottom. Only one side is land, so we come here and trigger a Dfs here. So it will call Dfs, or if it's a small, so Dfs, this is row 1, column 1. Again look at its neighbors, nothing to add. So this is now visited. Its neighbors are this and this and also this. So trigger a Dfs here. So this will call Dfs 10, and here 3 sides are water. So it will call sum plus equal to 3. Similarly, it will be visited and come back to here. Next unvisited is this. So come here, look at its neighbors. Again 3 will be added. So here we had added 3. Here we added 0. Here we added 3. Then come back here and trigger Dfs here. Here also we added 3. Then backtrack. Next unvisited is this one. So come here, look at its neighbors, 2 sides. Then mark it visited. This side is visited. Come here. Again trigger Dfs here. Look at the 4 edges. 2 is water. Mark it visited. Next neighbor is this. Come here. Mark it visited. Look at its sides. 3 sides. And now there is 3 neighbors are water. 1 neighbor is land, but it's visited. So Dfs stops here. And whatever is the value of sum, we return. So it's 3, 3, 3, 3. That is 12 plus 4, 16. So this way also you will get the same answer. So I will write this both codes in C++, but in Java and Python, I will just write the iterative one. So this is the problem, and I had taken this same example. And here you don't need to worry about edge cases, that is empty grid or so. They have given that there is exactly one piece of land. So that means the grid is not empty. So first let's write the iterative solution. Let's save the row and column into a variable. We will need it multiple times. If it's water, we will just continue and not process further for this value of ing. And you can do multiple things here. One is that you add check like I is greater than 0 and grid I minus 1 j is not land, then add 1 to it. But here two checks are required, one bound check and one the value check. So better to take perimeter 4 beforehand. So we have assumed that all 4 sides are water, and then whenever we encounter a land, we will decrement it. So if here we are done with one step, obviously we will write for all 4 neighbors. But if you are adding perimeter, checking if it's water or not, then if it's this row 0, I is 0, then we will not have this neighbor, this grid I minus 1j. So we will have another check that if I is 0, then we will definitely add it. Since grid ij is 1, it's land, otherwise we would not have come to this line of code. So we need 2 checks. If I is 0 or I is greater than 0 and grid I minus 1j is 1 is 0, then add 1. So to avoid that, we added 4 beforehand, and whenever we encounter a land, we will decrement its value. So here we simply need, so it will automatically add these values as water, and we will only be checking within this grid. If it's land, we will decrement, since it's guaranteed that in the top there cannot be land, so there is no point in checking. So these are for 4 neighbors, and this check is just bound check, that we will only look for this cell, we will not look below it and left of it. Similarly for this cell we will not look at right of it, for this cell we will not look at left of it. So on the outside it's assumed that it's water, so no need to take care of that. And finally return perimeter. And this works for this case. Let's submit. And the solution is accepted. So it's around this range. Now we will write the Dfs solution or recursive solution. So let's comment it out. and again initialize this. So if we encounter a 1, then we have found a piece of land, so we will start DFS from there. We will define this DFS shortly. We need to pass the grid, we need to pass the row and column, and we will also pass the parameter by reference, or you can also make it member variable of this class. And finally we will return perimeter. Now let's define this DFS. And we will mark it visited, so for that we can use make it 2, so 2 denotes visited, and only cells which were earlier 1 are converted to 2, 0 remain as 0. So what we will do, we will check if I is 0, that is first row, or grid I minus 1 j is 0, then perimeter plus plus. So first we will whatever cell we are at, we will mark it visited, we will look at its neighbors, how many sides are water, we will add that to parameter, and then for each of the neighbors which are unvisited, we will trigger a DFS. So first let's add the parameter. We can mix it in one also, but that will add few more conditions. I want to keep it simple here. So if it's I equal to 0, that is first row or last row, then automatically parameter we will increment by 1, since those sides are water. If not, we will check if top or bottom are 0 or not. So these are for top and bottom, and we will check for j for columns, that is left and right. So if it's last row or grid I plus 1 j, and the same for columns. So we have incremented the perimeter looking at the sides. Now we will do the DFS. So if I is greater than 0 and grid I minus 1 j equal to 1, then DFS I minus 1 j and or I less than grid dot size minus 1 and grid I plus 1. So here we looking for top neighbor, here we are looking for bottom neighbor. So I plus 1 j. And ultimately this DFS will visit all the lands and also keep track of perimeter. Now let's see. Line 33. And the answer matches, so let's submit. And we got some heap overflow. So here is the mistake. It should be grid 0 dot size for number of columns. And this solution is accepted. Now in Java and Python we will do this iterative version only. And the solution is accepted in Java. And we are right here around 99.93%. So that's good. And finally we will do it in Python. And we have not we did not convert that 2 back to 1 in our earlier DFS solution. In the end you can again run through this grid, and wherever you find a 2, replace that with 1. So you can do that, but that was not required here. And the Python solution is also accepted.